Here's another example. Factor x cubed plus 3x squared plus 2x plus 6. Okay, let's try and substitute the divisors of 6. Okay, starting by plus and minus 1. Plus 1 certainly doesn't make it 0 because everything would be positive and greater than 0. How about minus 1? That would be minus 1 cubed, minus 1 plus 3, minus 2 plus 6. This is 1, this is minus 1, 0, plus 6. And that is not 0 also. That doesn't make it 0. So, before I go further and substitute 2 plus and minus 2 and plus and minus 3 and plus and minus 6, the divisors of 6. As you look here, if you take x squared and write it this way, take the x squared outside and write it, that would be x plus 3. Okay, now how about this? If you take 2 outside, that would be 2 times x plus 3. And this is this. Okay, so here we have a common factor, so we write it as x plus 3 times x squared plus 2. The method I gave you about the substituting the divisors of 6, as you saw it in the previous videos, might be frustrating kinda. And in some cases there should be some easy ways like this. Okay, factor this: x cubed minus 8x squared plus 17x minus 6. Again, we got 6 here. Okay. We could try and substitute the divisors of minus 6 here. This is one way, and another way is doing by the method of the previous example, which doesn't work here, because that would be x squared times x minus 8, and that would be 17x minus 6. And we couldn't write it as in the better form. Okay, but one way is to write the 17x as, let me write it here, as x cubed minus plus 17x is 15x plus 2x. This is 17x. This is minus 6. Now, this would be equal to x times x squared minus 8x plus 15. Okay, now how to factor this? We should find the R and S whose sum be minus 8 and whose product would be 15. What are they? Minus 3 and minus 5, whose sum is minus 8 and which product is 15. Okay, so that would be x times x minus 3 times x minus 5. How about this one? This is 2 times x minus 3. Okay, we got common factors here. So this would be x minus 3 times x minus 5 from this plus 2. And if we could multiply x by this to see if we could factor this also. So that would be x squared minus 5x x squared minus 5x plus 2. Okay, you know, the factors of this would contain some crazy numbers. I'm not gonna do that here. Okay, and you know, this method I did here needs, you know, if you want to be good at it, you should do more practice on factoring by this method. You know, it's not an easy method. Requires more practice in order to become advanced at it. Okay, let's do some other example of that. How about this? X to the power of 5 plus x plus 1. You know, first try and substitute the divisors of 1. What are they? 1 and plus 1. 1 doesn't make it 0 because everything would be positive, greater than 0. How about minus 1? Minus 1 would be minus 1 plus minus 1 plus 1. That is not 0 also. So, you know, even doing that by the frustrating method doesn't work here. Okay, but let's do this. Add it by x squared and subtract it by x squared again. So this is 0 and changes nothing. But that would be help us factor this. How? me. Oh, I got that. You take these two, that would be, and take x squared outside, that would be x cubed minus 1. Okay, plus the rest, plus x plus 1 plus x squared. But we could factor this also by the difference of the cubes identity. That would be x squared times x minus 1 times x squared plus x plus 1 plus this one. And this is this one. In which this one is written first and x is written second and the 1 later. Okay, so what that would be equal to take x squared plus x plus 1 times x squared times x minus 1 from this plus 1. That's it. You could again multiply this by this and see if you could factor this also. Okay, I'm not gonna factor it. Let's do another example.